M1 Dynamics example 23. In this example, we're given slightly different information, but it's exactly the same principle as before. In this case, we've got two particles A and B with mass 2 and 4, respectively. They're moving towards each other along the same straight horizontal surface, and the particles collide. Before the collision, the speeds are 3 and 2. We know that they're moving towards each other, so that will be the speed there. And then afterwards, we're going to have to find the speed and direction of A and the speed and direction of B after the collision. So I'll call this, let's see, presuming that they bang into each other, let's assume they bounce off and go in opposite directions. If that assumption works out to be false, one of these will have the opposite sign to what we're expecting it to have. But I'm going to assume that these two particles come along and collide and then bounce off in different directions. Now we're told that the impulse in the collision is 7 Newton seconds. So that means that this particle has got an impulse of 7 to the left, and this particle equal and opposite in the opposite direction would have an impulse of 7 to the right. So if we consider each particle one at once, for particle A, if we do impulse equals mv minus mu, we need to make a decision about which way is positive. So if I look at this situation, most things are to the left, so I'm going to take to the left as positive. So the impulse is to the left, that's positive, that's 7. The speed afterwards is to the left, I've called it VA, velocity of A. And then initially the speed was to the right, so that will be negative, and we're subtracting it. So that will obviously become a plus in a second. So we're going to have 7 equals 2 times velocity of A, and then it'll be plus 6. So if I bring the 6 over to the left, 1 is 2 times the velocity of A, and so the velocity of A is half. So that's 0.5 meters per second to the left, or in the opposite direction to the original direction of motion. So that's part A done. We've found the speed and direction of A after the collision. Why don't you pause the video at this point and see if you can repeat that process for particle B. So repeating the process for particle B. Again, because most things are to the right, I'm going to take to the right as positive. So the impulse is 7 to the right. mv is going to be 4 times the velocity of B. And then we have 4 times, and if I'm taken to the right as positive, this 2 will be negative. So 7 is 4 times velocity of V plus 8. Bring the 8 over, that's minus 1. And so minus 0.25 is the velocity of B. What that tells us is that the direction actually isn't to the right, it's still going to the left. So it was originally coming to the left with a speed of 2. Now it's actually still going to the left, but with a speed of a quarter. In other words, the collision hasn't changed the direction of this particle, it's just slowed it down. So the velocity is 0.25 meters per second in the original direction for B.